Let's start by putting our name and date on our notes. We are doing 3.1 today. We are going to solve one-step equations. And our essential question how do you solve one-step equations using algebra? Please notice that I have already started your notes with vocabulary. If you need to pause in order to copy it down, please do so. Inverse operations are two operations that undo each other, such as addition and subtraction, or multiplication and division. Equivalent equations are equations that have the same solution or same solutions. And I have a note over here on the side. Equations are actually balanced systems. In order to keep it balanced, you have to do what you do on one side, you have to do on the other side. Think about a balance scale in science. If you balance that scale and then you put something more on one side, it's no longer balanced until you add an equivalent amount on the other side. And that's what we're working with here, solving equations. Example 1. Okay, I'm going to show you my method. Doesn't mean that this is the only method, but this is my method. I always recopy the equation exactly like it is in the book, on the worksheet, wherever. And then I want to build a wall, okay, because I want to make sure I keep straight which side is which. Then I want to look at where my variable is. What am I doing to that variable? Well, I'm adding 7. How do I undo adding 7? This is what I want to change. That's what I want to remove. Well, I'm going to subtract 7. But I have to do it again on both sides. So what's going to happen here is that plus 7 minus 7 goes to 0, so it goes away. And I'm left with x, and I want to bring that down. And then 4 minus 7, use your calculator if you don't know, but that's negative 3. And some would say, oh, wait a minute, you've solved it. No, I haven't solved it. I have a possible solution. I need to check it. I go back, I write down the original equation. Then I substitute in what I think my solution is. Now notice at this point, I'm only working on the side with the variable. Negative 3 plus 7 is 4. When I get this down to a single, then I bring this down. Oh, 4 equals 4. That checks. So now I can go box or circle or highlight my answer. Now let's go back and let's look at what we did. We wrote the equation. Actually, we rewrote it, didn't we? Then we built a wall at the equal sign. Then I showed my steps. I showed the undo. And I did it on both sides. Then I simplified. Then I have to check my solution. I always look at it this way. I want to know I made a 100 on this paper, so I'm going to check every problem that I do because I want to make sure that I get them right. I don't want to make a mistake. If this doesn't come out equal, then I have to go back and check my work somewhere. Example 2. Again, rewrite the equation. Build the wall. This is what I want to undo. Addition undoes subtraction. And I do the same thing to both sides. This cancels it out. It goes to 0, however you want to look at it. I pull my x down. 3 plus 12 is 15. But now I have to check it. And I go back and I start with that original equation. Then I'm going to substitute in. This one's easy. 15 minus 12 is 3. And 3 equals 3, so that checks. So I can box or circle. Now, to work, to solve, you cannot use the calculator. Okay? No calc. To check, yes, use your calculator. But you kind of have to go through this process still. I still want to see that you copy the original equation, you substitute it in, then put in 15 minus 12 in the calculator and get the answer. That would be fine. Okay. Example 3. Please understand that in these notes I am modeling exactly what you need to do. Copy the problem down again. Built my wall. Now, what's happening here? Negative 6x. Negative 6 times x. So what undoes multiplication? Division. And the easiest way to show division is to use a fraction bar. And what's going to happen here is that negative 6 divided by negative 6 is 1. This one isn't 0 like up here. This is 1. And 1 times x is x. Now, here, if you need to use a calculator to figure that out, go for it. Not a problem. Negative 8. And of course I have to check it. So negative 6x equals 48. So that's negative 6 times a negative 8, which is a positive 48. That checks. I can box my answer. One more example. Example 4. Okay, x over 4 equals 5, or x divided by 4. And this one gets a little bit different, y'all. This one does. It does get a little bit different on this one. You still have to undo. Multiplication is what undoes division. So I want to multiply on both sides by what I'm dividing by, which is the 4. Now over here, I kind of need to remember to turn that whole number into a fraction. Oh, and then look what happens. Do my 4's divide each other out to 1, which leaves me x equals 5 times 4 is 20. But of course I have to check it. 4 is 5, so it checks, so I can box my answer. Now, that's one version of a fraction. Let me do one more, though, that shows you another thing that you can do with division or multiplication, depending upon how you want to look at the problem. What if I had negative 2/7 x equals 4? Well, here you might want to remember reciprocals or multiplicative inverses. Remember where you turn a fraction upside down? So copy down the problem again. Build your wall. This is what I'm multiplying by x. But that's a fraction. And in order to turn it into a positive 1, I need to multiply by the flip. I want to turn it upside down. So it becomes negative 7 over 2. And again, whatever I do on one side, I do on the other side. Now, negative times negative is positive. 7 divided by 7 is 1. 2 divided by 2 is 1. So I've got 1 times x is x on that side. Remember to turn this into a fraction by putting it over 1. Oh, wait a minute. 2 goes into itself 1 time and into 4 twice. Can I reduce that before I actually multiply it? The answer is yes. If you don't want to think about that, could you use your calculator? The answer there should also be yes. But I've got 2 times a negative 7 is negative 14. And of course, before I can claim that's my answer, I have to check it. So negative 2/7 x equals 4. Negative 2/7 times negative 14. Oh look, negative times negative is positive. I can put that over once, 7 into itself once, 7 into 14 twice. 2 times 2 is 4. That equals 4, so that checks. And I can circle or box my answer. No quick check today. We will do more of this in the classroom. I will see you tomorrow.